Well, thank you. Today I tried to prove that I'm not only the DevOps one-trick pony, and I can do also something technical with mobile stuff. I work for a company that does apps for TV shows, and so we're doing the interaction on your phone. That's easy, but we're also doing live results in the studio. We have a control center in the studio, and we're actually part of the show. So if our tech fails, there is not much of show. So it's really like Formula One, the tires, you have to be there, it has to work that 1 hour. My definition, or the way, like after 5 years, how I interpret DevOps. And I think there are like 4 typical areas, or let's say phases a company goes through. The first one is they put like extend the delivery to production. That's typical, your pipeline, your delivery, let's speed this up, and that's it. And then when they get that right, they get everything like monitoring and metrics and loggings, and they get all the information back into the actual project so they can learn. It's a typical phase, how you go through. And then the next part is that once the tech settles, you come to think more meta, and then you put knowledge about everything you do. It's not about it has to work. No, why does it work? Like, why are we putting this out? And then everything floats back to the business, so they can make new decisions, get better, like influence. So the inner circle is typically the tech circle, and the other one is typically more like the business side that you want to improve. All the slides are already online. There's going to be a lot of tooling in there. You don't need to note down all of the links. There's about 100 slides to go. CI pipeline. It's very difficult because the audience, some people have never done mobile, and some are doing mobile. So I'll start with the CI pipeline, which is about half of the talk. And then there's like 2 other parts. This is a big diagram, but I'll skip that one, but it's in the slides. So the first thing you need to do if you're doing any CI building for iOS, you need to find a Mac. Because you can't compile it on all the other stuff. We use Circle CI. They have, it's a hosted service, and they have Mac support. Travis CI has support. So that might be your easy way in. Instead of having to buy a bunch of Mac minis or whatever, you have to control yourself. Then you need to get the SDK installed, Xcode as a compiler and so on, or Android with all the tool sets. These are like little scripts you can do. Don't type them now. But the idea is that you can automate this. So you don't have to worry. You can even automate Xcode that asks for, do you agree as a button and closes. So it's there somewhere in the slides if you need it. Then the next thing is, iOS has this concept that you have, when you build the software, only certain people are allowed to build and sign the code. This snippet will explain you what you need to do on your CI setup. And what it does is that you create a new keychain, import all the keys, make sure the keychain doesn't lock after a certain time, and then you can use it. Every command can use that keychain to run your build. So it's one of the steps while setting up your CI that you need to do. OK. If you're familiar with Maven and Gradle, that's easy for Android. Cocoa Pods, it resembles a little bit like Ruby gems. So you have a podfile.log. So you have all the same problems as dependencies, versions that you need to control. So that's not different than the usual web stuff. The first trick you hit is that when you're doing Xcode, you are like defining a set of build features or configuration settings. You need to share it. Like it's a flag, and although you could do it programmatically, they're the easiest ways to open up Xcode, set the flag, and save it. So it's like one of the things that's not easily automated. But this gets checked into your version code, so after that, you don't have to worry about that. OK. So we as a company, we typically build apps, and we have a staging app, a production app. So these are two different apps. And then we have the iOS App Store build. The reason is that those two we can just use internally, distribute internally without having to go to iTunes Connect or the App Store, and we can make it much more faster. And we use visual cues to indicate which application they're using. So typically, the first one for staging has a newer version than production, and we release it to different people for testing and so on. So this translates into a set of build configurations where development that is used by the developer on his laptop against his local server or code or whatever. Then staging for more testing, production, App Store. And the build configuration will change the API entry calls where it goes through. So it's a way of switching using the same code but targeting different environments for the code. The same is true for Android. They call it build flavors and production flavors, but it's the same concept. You define a set of variables for that build, and you define for what environment you're building. Because the first call is the API call, and that needs to be compiled in the app. It's a bootstrap call. If you want to have like readable builds, it's basically condensing all the output of the compilation and putting it in a nice formatted way with highlighting. You can use something like XCTool. And then like you would do on other compiled code, you can do static code analysis to detect memory leaks or like sloppiness of IDs that are defined and not used, that kind of stuff. So that's not too different, but it is useful. Facebook released a new tool, FBinfer. So if you're already doing that, it puts like all of these tools in a new rule set, and you can actually use that. Then there's a few services that you can use to, we're not doing it, but I'm giving it for reference. If you want to have like mobile security scans of your APKs or your stuff, mostly they look at the versions of the jars you include, and you like third party, if they know any vulnerabilities, and they report on the versions. It's still like, I think, land in progress, mobile security there for good services. But if you know any, I'm happy to add, so tell me about them, and I'll add them to the slide deck. Then when you build for iOS, so you compiled everything through, you cannot just give the binary to a person and have him install it on his phone. You really have to define, sorry, this is the next slide, I guess. Yeah, okay. Context. This is just a way of when you have the file that you compiled and you want to distribute it to a mobile phone, they cannot, on iOS, they cannot say like download file, open, and it's installed. It has to go through a certain way that it gets onto your phone. On Android, that's easy. The compiled file, just you can execute and say, I trust local files to execute, and the APK and the software is installed. But on Xcode, it's unfortunately not that easy. So you need to distribute the builds. We're using beta from Crashlytics. It's a free service. It's now part of the Twitter mobile ecosystem, and it allows you to add a list of testers and versions. And after you build, you upload it to there, and the people get an email, and they can open the email on their phone and install the version or the next version. So this is a bit different than typical web, that you have to go through these hoops to install the software. Apple limits if you're not in the App Store based on the device ID. So the one build, it's not only distributed, you have to allow certain devices. So the first thing you'll have to do is like, who needs this testing? Like, hey, open this website and find the UDID of the device. And that you have to add to the system so they're actually allowed to install the software. There is a limit of 100 devices typically in the normal subscription from Apple. You can go for the enterprise subscription, and then it's unlimited. But a person can only belong to one organization at a time. So again, a lot of hoops from Apple that you have to jump through, which you don't know if you come from the web. So this tool will allow you to automate that. You get to UDID, and you are have a CLI that you can just say, I add this device to the list of that is allowed to run this test. So again, automation. For Apple to allow a build to be installed on certain devices and signed by certain people, they have a concept called provisioning profiles. It's basically an XML file that contains a list of developer certificates. But here are a few commands that you can actually use the typical OpenSSL commands if you want to look at what's in that profile. I know it looks like hokey pokey, but if you ask that to a developer, they say, yeah, it's a mobile provisioning. But if you have to automate, you really better know how it is and how it works. Most of them developers I've seen, they're in Xcode, and Xcode has a button, fix certificates, and then it invalidates all the certificates in your account. It's not very useful, and there's not a good way to disable it. So you really have to say, we got this covered in another way, and then they will not touch that button. So like I said, we distribute the app. So the user has a beta app on its phone, and he can list all the applications he's allowed to test on his device. And he will get an update or a ping every time a new version arrives when we build it. Another way I've seen it is by people using QR codes to have a link, and immediately you scan it with your phone on Android, gets the link, app gets installed. It's a more convenient way sometimes. And especially we put the version in, so we actually know when somebody from the testing complains which version is he actually using. Yeah, the version is below unreadable, I'm afraid. One of the tricks we use for feedback is that when you shake the device, there comes a pop-up which allows the user to easily type his message and send it to us as feedback. So it's a very convenient way. He doesn't have to go to his email. He's in the app, just shakes it, types his, and goes on. There exist solutions that you can, so you have a build for a mobile device, typically compiled for the architecture of the device. But there exist solutions, and it's sometimes handy, to run a build in a browser. We use that for customers who don't own mobile devices themselves, as strange as it sounds, or don't have a convenient way to test it. We just make a simulator build, upload it to this site, and you can just click through the whole app as it is normally functioning. It's a little trick, but sometimes it's very helpful. And we also, depending on what we want to do, actually record the sessions. The nice thing is that when the movie plays from the recording, we can see network throughput and CPU performance. So if they tell us we hit a problem, we know when they put the message in. So we kind of know where in the video it is, and then we start looking what happened there. So it's a way to get faster feedback instead of what did you do? And he has to remember how to repeat the sequence. It's a very convenient way to actually grab the information. Next block is testing. We have a very strange or unusual use case. We make throwaway apps for TV, so they don't have an extended life. The regular testing slows us down because the features are constantly changing while we create the app. but we have a phase after we build the app to stabilize and do manual testing. So it's not your typical thing that you do if you're like building on a longer term app. But for us, the most important thing was to get the feedback or the app to the users. I have to verify that it's the functionality they like. And they're like coping for us as testers in many ways because our logic is typically quite simple. This is not, a full feature e-commerce site that we're building as a throwaway thing. So for us, it works. So this is the caveat when I'm explaining things. But we are getting more and more interested to actually run scenarios like little logins and see, like, especially when you have Facebook login or not login, does everything work? Is the logic okay? So there's a few frameworks out there. Calabash and Appium allow you to write user tests that you can reuse for both Android and iOS. There's other toolkits that are around that allow you to write for one or the other. But if you want to reuse your tests in your scenarios, you can actually use both. So how does it work? If you're used to Selenium testing, it's much easier to put a label to things than it is to say, like, label 1, text button 3, and do all that stuff. Because once the ordering of the UI is changed, then you have to rewrite your tests. So both Android and iOS tools typically work with adding accessibility labels for like the blind people, and they use those as labels that you can create your test for. So this is much more robust than saying like text field 1, blah, blah, blah. And you can record that if you want to. But this is an example of Appium, where you can just say, I type a command, I do the answer, and so on. And you can create your own like little commands in it. It's called page objects, where you can just feature like reuse little commands that you're reusing your test all over and over again. So that makes it easy to repurpose parts of your test logic. The next thing is especially on Android, there's so many devices or form factors that you have to be aware of, or API versions. And then a simulator is quite handy because you don't own all these devices. So a developer typically tests in a few of those devices with a simulator, and it uses hardware acceleration on your Mac or something, so it goes pretty fast. So it goes faster than the actual Android testing tools that are delivered. It's something like Genymotion, it's called. It just boots up a virtual box. The mobile device is running inside it, and you can drag and drop and click everything with it. If you want to get fancy, there's like Vagrant for Android. You can run Android in a Docker box. People are doing crazy things with that stuff. Unfortunately, you can still not run Xcode in Docker, although there's somebody who created like an API that is like Docker that allows him to spin up on a Mac these simulators and stuff. So it's kind of fun if you think further. For us, the real, we don't have any users before and after the show. So for us, we don't have a test audience like slow ramp up. We have the people from the studio, maybe people that are involved, but we typically don't have like a larger audience that we can like beta test and go through. That's why we are, in the beginning, we were hitting a lot of things that weren't working on certain devices. So for us, it was super important to actually be able, A, that the app starts on a certain device, B, that it looks good as the form factor, and 3, that it was like performant. So this is like one run we did, and we get the screenshots from each of the real devices. This one is on, I think, a Samsung on Wi-Fi. And the most important for us is like the designer just watches visual differences on the screenshots. So we kind of see that the screen is not like totally unoverlaid. And if we see too much problems, we just disable that device. Yeah, that's how we work. Luckily now, more and more device farms are spinning up. Like Amazon has now a device farm as a service. In the future, when you submit a new Android app to the Play Store, they will run it through real devices to see at least that your app starts. Currently, they don't care. You push it, it gets into the wild. But they are having, like Amazon, they will have like a cloud offering for Android testing that you can just sweep it over a set of devices. This is not cheap. Like for us, at least. For others, maybe it is, but I don't think there's a service that starts lower than $1,000 and that may be like for a couple of hours of machine testing. So it's way more expensive actually than servers, this thing. But the way we use it also for debugging, if somebody reports that he has a problem on a certain device, we look which of these device forms actually has that device, and then we run the test on that one. So it's also like a troubleshooting tool if somebody reports too many problems with a certain device. Then if you want to go a step further, the previous ones were all automated. Upload like your code, upload your tests, run, this is the result. These two actually allow you to have an interactive interface. So they boot up the device, and then you can click and just do everything yourself. Like Sosta is able to record that and then replay your tests if that's something you want. But sometimes, you spend too much time automating the tests or figuring out what fails, then it's easier to go manually, and then when it's in that state, you look like, hey, what's happening? Again, expensive stuff, I'm afraid. The next thing is like, okay, there has been an issue, it's not loading, it's slow, and so on. In the web, we're like, with the whole Chrome Devtools debugging, we're like so happy with that. These tools allow you to do the same. You put a plugin in your app, and then you can remotely see whatever HTTP request or images or local storage they do. I think Stedo was released by Facebook recently, but it's really useful to actually see the timings or the load sequence and so on in that stuff. And one important thing you also need to test is like, if somebody's on a slow network, you actually also have to see like, how does it behave? Does he get any response or not? Or like, do you want to tune the welcome message that's pretty fast, so you already get some feedback? Is the spinner working okay? So we use Charles Proxy for that as a way to throttle the bandwidth during our simulator tests. And then this is also maybe specific, but once you've built a binary and you signed it, with the mobile provisioning profiles and so on, we often don't have access to the iTunes store or connect from our customers. So we have to deliver a binary, but we can't really test it. So that's why we have the production build, so the staging and the production build. And then the production build, if that works, we re-sign it. The customer re-signs it with his private key, and then he has his binary. And the nice thing is, like, we know that the code is the same, but it's just re-signed. So that way we actually know that the binary they're building, they don't have to rebuild the code, because then we don't know which dependencies they pulled in, or whatever versions they got. By putting just the binary and having them re-sign, we know exactly which code goes live. It depends on like what access you have. But obviously, it's much easier if you can just like have your pipeline, you compile it, you're like everything is there, it's tested, validated, and then you just want to put it to the Play Store immediately. So There's plugins that allow you just to go the whole chain through, like I explained, click of a button, save, build, blah, blah, blah. And we often, the production build, we just push to the beta channel of the Play Store. So it's already there. So it's only the promotion from beta to production that we have to do manually if we're satisfied. But the builds go out all the time to the Play Store in beta channel. And I think the last 2 months, there's a guy who has the Fastlane Tools project, and I think he rewrote all the iOS automation tools in one suite. So you kind of have a build file, and he's able to compile, take screenshots, upload your metadata, and upload it to the App Store, all automatically. It even creates like automatically an app if you want to produce. So all these tools, this is really the suite that you have to be looking at if you want to build the automated pipeline. So this is the pipeline. It's all fun. Now we push the button, release. OK. This is easy. So this is all you know. You watch the API on your dashboard. You use Datadog. We get all API timings, 95 percentile. You watch all that stuff. But what about your mobile stuff? Because it's a 1 hour, we really need to know like how many people are downloading it now, and not like after a day. Fabric, the Twitter tool, allows you to like whenever somebody downloads, you see like immediately real-time stats. And you can track like, hey, so many iOS, so many Android users are downloading. It's annoying that we can't export the metrics from that system. So therefore, we also watch just Google Analytics for that stuff, because it has a real-time function. And then for archiving, we're now using Aws Mobile Analytics. So we actually send our metrics to the three systems. And then when we have to watch the show live, we're actually tracking these three in real time. But, we've seen all the errors on the back end if we have to. But how do we know that the devices are not having an issue? We use a New Relic plugin in our app that is able to see the timings from your app. For example, we can see sometimes in the morning in Belgium that the Facebook login API isn't responding because we see all our users having errors. Or the ads network is down. Like things would be very hard for us to see if we don't get that reported from the users themselves. And you can even see like memory usage from the app or the timings. So what you do for the service, you now do also for the devices. And you actually see the memory consumption and so on. And I learned that the people from Dynatrace are able to drill down to the user for this stuff. This is like a more generalization, but they're able, like, this user had an issue, and what's his time, what's his memory usage. It's pretty cool. So this helps us to see other problems that we can't see on our server side. And then, of course, the crashes, the app crashes, due to various reasons. There's very strange crashes that you don't understand, and that only happen a few times, and there's more. So typically, we haven't been able to solve all the crashes we get in. We just go for the most number. Some are just weird states of devices that we can't handle. This is just from our test system. But you can immediately see, like, on this version of the app, this one is happening the most, and you can see, like, did it reoccur in the next version? And so we kind of get a regression going, how that means. And you get pretty detailed, like, is it an iPhone? What was the battery state? What was the memory consumption? With threads were going on. So you can see all that stack trace going on from the device. And then you can kind of, hey, this crash only happens on iOS 7 with this kind of format factor, so you can learn a lot from these. But obviously, being in the charge of metrics, there's also login. And we log directly from the mobile device. So the logs don't go through our system. We log everything the API does internally. But we also have the devices log their stuff immediately to a system. Sorry, this is kind of out of the place. But for the crash reports, we also see which user. So you can tag which user did have this problem. And that means that we can actually filter and see in our backend, there's parts of the backend that's here. And this is, for most developer, has been a learning curve. For them, logging was debug or not. And we had to learn them that, we use 50 is fatal, 40 is warning, 30 and so on, and that we can actually have the granularity so we don't get all the logging or not. And that you're even able to read the iOS logs through an API, and the same for Android. So when we hit an issue, we set a debug flag for that user or for that type of device, and we're able to read in retro the error log or the logcat or whatever that user had, so we get that extra data. So usually we don't have them send all debug requests, just the errors and the warnings. But if we need to go deeper, we can just enable that and get logging of the device and send it to us too. Obviously, when you launch, you watch Twitter as much as you do your metrics, because the feedback will go there. And then, especially in the beginning, you watch your Play Store, what's your review, what's your star rating, because this is the channel that people are used to. Oh, it doesn't work. Okay, it's really annoying because you cannot, well, at least on Android, you can reply to a user, but you have no context. Maybe a little bit on the version, and that's it, but there's no context. On iOS, you can't even reply to a user. It's really annoying, especially during that 1 hour and they're there and you cannot learn what they're doing. So we use a system to get the reviews into Slack, so at least we get that already automatically from both the App Store and the Play Store. But we really changed the way in our app that we get feedback from the user. You might typically think okay, your email, you hit a problem, send it to us. But we went a little bit further. We use Freshdesk, and it's like a live chat system. And it immediately, when a user responds from his device, we get all the context from his device and versions and so on. And we even add additional stuff, and we get his log. So whenever he says, I'm hitting a problem, we immediately get the context of that user. And we try to channel people through that way to get to the help or report an issue, then go through the App Store. Because that looks bad, and you can't do anything with the data, really. And the nice thing is, if we solve this problem, it gets into a ticket system. We can reply. He can answer. You're OK. And then we say, you're happy. You want to do our app review, and our ratings go up. So it's a little trick, but it's very important to have that star rating and not one user who puts a bad rating because he has just one issue with his thing. So this is kind of the live chat that he has. This is for us the help. The frequent asked questions. There's a live help, and we put the user through that. And then we can give him notifications on a personal base and say, OK, you have an issue, or we're doing something special for you. FAQ. In the beginning, we coded that into the app, which is totally stupid. And then we move that to a central system so we can kind of keep changing that on a continuous basis. And like I said, we ask for a review prompt. And the next thing we need to cope with is that all the versions of the app that go live, not everybody updates. So Apple has this auto-updating, but some people disable it because, that's bandwidth and it's not automatic, like okay, whatever. And so we build in a way like when the app starts, it checks the App Store version and says to the user, I have actually a new version. So we do that in the app. And that reduces our version difference, I think about 70% of the people do auto-update in our findings, and the others we try to convince with that, and we're getting close to only like somewhere between 5 and 2% that haven't updated, especially for the shows. Might be different for your environment, but they typically know if there's a new update, there's a new feature, and I want to do it for the next show. So, and then we haven't tried this one, but there even exists like share your screen. So when the user hits like live chat, he has a problem, you can say like share your screen, I can watch along, see what you're doing. So this is kind of the same what we try to do in the web, but you can get like pretty far in that stuff. So our team channel on the left is, the build, server, deploy, and all that stuff. And on the right, it's the alerting, the crashes, the iTunes review. So we have that in the same channel. So there's no difference for us. Backend app, we get that all in the same channel so we can watch actually what's happening. So it's a quick run through, deploy, get all the feedback back to the project, like crashes, whatever, and make that happen. So this is the elephant in the room. Yeah, you do have to go through, on average, 6 or 7 days of approvals, which is really annoying. Remember that bug, no, not the bug, but the version thing. I think 2 weeks ago, I put a new version live, and that logic for checking the new version had an issue. And for some reason, the language translation didn't come into the app, and that means that it will try to locale that wasn't there, and it says like, poof, done. So as soon as I put the new version out, all the older versions said like, can't start, like, oh, new version, bad, new version, bad. We had a fix in 2 hours, submitted it to the App Store. 1 day later, we will look at your app. 1 day later, approved. So this was an expedite review we asked, but because it's a shared account, this is shared across a lot of apps from this customer. And they said, well, you've been asking expedite reviews so much, but apparently they keep kind of counters how much expedites you can ask, but they keep it per customer, not per app. Really annoying. So we figured we had to find a way to limit the number of changes we could do to the app for not going through the App Store. And this is our app. It has like native stuff, web stuff, and so on. I'm going to go through the most important part because I'm running out of time. We have a way for remote configuration. So for changes in the settings, we don't have to do a new App Store submit. Trivial. Any localizations, change of wording, we get that remote. So we build a version into the app, but we also can update that remotely. So typo stuff, typically, that we don't want for a new submit. Even UI features, you don't have to go. UI is data, it's not code, so Apple allows you to, whatever you change to the UI, you can actually change without going through the App Store. For Android, we actually bundle the browser inside the app, so the compatibility of the library is much better, and we have to do less fixes. So it's one of the ways of not having to resubmit. For each of the devices. React, I'll leave that as it is. Then we started creating a bridge between native and web. And you're allowed to change web stuff by Apple or web views as long as it doesn't change the purpose of your app. So you see, you do part native, part web, and the JavaScript you can actually change unless you have like a big change. It's really stupid if you think about it, because we can easily write like a feature flag that says, hey, I'm Apple, you're testing, you get a different view of the app. It doesn't really matter, but And then when you look at how they test, sometimes we only see like 4 requests to start the app and I close it. So I don't know what they do for it. So we have our native app and we embed PhoneGap. So we can actually also, PhoneGap allows you to bridge native and web. So if the native hooks are already in place, we can call them from a new web page. So this allows us to bring new functionality into the app without having to change the code. And this is for reference, but if you're like already in coding, you're able to load storyboards, zip files, all that stuff from a remote bundle. So even those you don't have to resubmit to Apple. As long as your IDs match in your views, you're able to just update those remotely. Not a lot of people do that, but it's actually possible. And then maybe, want to take that a little bit further. This is Live Patch. It's a way that this wraps, it uses a technique called swizzling. It wraps around each function in your app. So you install it as a plugin, it wraps around each function, and you're able to control the result of that function from remote. And then you can just say, this one, if in my case, for the version check, I could have said return true, return false. And I didn't have to do anything of a code change. So this is pretty fun. We haven't done it yet, but it could have been really useful for us. I don't know, I'm running out of time. Maybe we'll stop it here. The rest is online on the slide, so I don't know if there's any questions so far. No questions? Well, you can find me afterwards if you want.